Okay, this first slide is just a little bit of a refresher. So tell whether the abbreviation identifies a congruent statement. Number 1, SSS. Well, that's yes, side angle side. How about number 2, SAS? Well, yep, that is side angle side. How about 3? How about SSA? Well, no, that is not one of those ways to prove triangles are congruent. How about angle side angle? Yes. How about angle angle side? Yep, that's one. And how about angle angle angle? Nope, that is not one of the ways to prove triangles are congruent. Can you conclude that the two triangles are congruent? Well, it says explain. Well, don't I know the reflectives are congruent? And I don't have any additional markings besides these right angles. So if I take a look, is this enough information to give me that the triangles are congruent? No. I would need another side or another angle. Another set of sides or angles congruent. All right, looking here at number 8. Is this enough to say the triangles are congruent? So I have two sets of sides congruent. This side is congruent to this side. This side is congruent to this side. Of course, you can always assume vertical angles, just like in the last one we assumed reflexive. So are the triangles are congruent? Yes. The reason is because of side, angle, side. All right, today we're going to learn the last final way to prove triangles are congruent. Before we talk about triangles being congruent, we have to talk about some vocabulary. Looking at a right triangle. How do I know this is a right triangle? Well, look at right there, I have a right angle. There are some key parts to this right triangle. We're going to deal with more of this in second semester. So the longest side of the right triangle, the side that's across from the right angle, that is called your hypotenuse. Say that word to yourself, hypotenuse. All right, so the other two sides are just called legs. So this side would be called a leg, and this side would also be called a leg. So those are the key parts of a right triangle. So looking at our last theorem, hypotenuse leg, if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Okay, so this is only specific for right triangles. This is really your SSA situation, but it only happens, so let's draw a triangle. So if I have two congruent triangles, and they both have right angles, so they're right triangles. In this case, your angle is always 90 degrees for this SSA case. You're going to be given two congruent sides and one angle. Well, since this is a special case, we don't call it this. We call it hypotenuse leg. Because in order for the triangles to be congruent, the hypotenuses would have to be congruent. So take a look. This is my hypotenuse. And then either leg has to be congruent. So it could either be this leg or it can be this leg. It doesn't matter which one. So for this case, I'm just going to mark this angle. So I know that these triangles are congruent because of HL, hypotenuse leg. Remember, this only works in right triangles. Right triangles, right triangles, right triangles. So take a look at this proof. I wonder if you're saying to yourself, well, nothing really looks different. So whenever we're given anything with right angles, take a look. This says perpendicular. Won't I know that there's going to be right angle somewhere? So you're going to have to plan ahead on these proofs. So if I know that these are perpendicular, wouldn't I know that these angles are right angles? And then BA is congruent to AC. Those are those sides. And then I would have the reflexive. So how are these triangles congruent? Because of HL. So that makes it different in our proof. So if I'm looking, statement. So if AD is perpendicular to BC, given. Always after perpendicular, we state which angles are right angles. Looking at this picture, if AD is perpendicular to BC, then we know that angle, what letter's in the middle? Hopefully you're thinking D. Angle BDA and angle CDA. What do I know about them if they're perpendicular? They are right angles. And that's your definition of perpendicular. Well, typically we say we go from right angles to to congruent angles. In this one, I don't need them to be congruent. I need for HL for them to be a right triangle. So in this case, I can say, okay, triangle BDA and triangle CDA are right triangles. And the reason would be definition of right triangle. Think about that. If you have a right angle in a picture, in a triangle picture, isn't that mean that this angle is a right triangle? So that's the definition of right triangles. So now that I've said they were right triangles, let's write down our next given. So BA is congruent to AC, given. What have we not put in our proof yet? So we have right angles, we have right triangles, that's needed. We have set of sides. Look at BA. Where is BA? Isn't BA the longest side? And same with AC. So these are my hypotenuses. So I need a set of legs. So why would these triangles be congruent? Let's see. So my set of legs would be AD is congruent to AD because of reflexive. All right, so for 6, the triangles are congruent. Because of hypotenuse, and then here was my leg, so HL. All right, let's look at another one. You'll have to play the next video. Okay, let's look at this next proof. So this is where I have to kind of map out my thoughts. Anytime you have right angles, we got to look. Is it going to be side, angle, side, angle, side, angle, or angle, angle, side. What would be needed for that? Well, you would need angles that are, you would first say they're right angles. Then you would say they're congruent because of all right angles are congruent. If you're looking for HL, you need the hypotenuse of the triangle to be congruent, a leg to be congruent, so just another side of the triangle, and you need it to be right triangles. That is everything that's needed for HL. So in this one, we kind of have to figure out, is it going to be HL or is it going to be one of the other ones? So if I mark this, let's get our statements going. So if I mark WJ is congruent to KZ, given. WJ is congruent to KZ, given. All right, so if I take a look, what's my next given? Well, my next given would be angle W and angle K are right angles. And the reason for that is given. So anytime you have perpendicular right angles, you're going to have to say, uh-oh, which kind is it, HL or any of the other ones? If I'm planning ahead, because step 3 is where they differ, you would either at step 3 say all right angles are congruent, or we're going to say definition of right triangles. So looking at this one, I'm given a right triangle and a right angle. I'm given that these legs are congruent. And in the proof, of course, we'd also have the reflexive side is congruent. Well, take a look at that reflexive side. What part of the right triangle is the reflexive side? Hopefully you're thinking, well, that's the hypotenuse. So since I have a hypotenuse congruent and a leg congruent in a right triangle, this one's going to be my HL. So the next step, step 3, the ones that differs would be, okay, first I say they're right angles. Then I have to say they're right triangles. So I could say triangle J, W, Z, and triangle K, ZKG, ZK, ZKJ are right triangles. How do I know this? Well, that's what the definition of a right triangle is. Isn't the definition of a right triangle that it has right angles in it? So we know we have enough information there. So the next piece would have to be my next given. Oh, I don't have any more. So the picture is going to tell me the next part. So what have we not included? So we've included the first given, the second given, the information we know from the second given. So the fourth step would be that reflexive. JZ is congruent to JZ. And that's your reflexive property. So now, do I have enough to say the triangles are congruent? Yes, I do. So this one, I know that triangle JWZ is congruent to triangle ZKJ because of hypotenuse leg, HL. This only works for right triangles. Okay, let's look at the next proof. So here I know that, let me get my statements. And my reasons go in here. Alright, so if I look, I'm given AD is perpendicular to CB. Anytime you have perpendicular or something that's going to have right angles, you have to check and see. Is it going to be HL? Is it going to be something else? Alright, so if I know this is perpendicular, let's just kind of map out my thoughts then. I know that the next part would be, well, if those are perpendicular, this and this are perpendicular, I would know that I would have two right angles, here and here. So I would know angle ADC and angle BDA are right angles. And that's the definition of perpendicular. Remember, I had perpendicular here, so here I have perpendicular as well. Okay? Alright, so now, step 3 is what changes. Is it going to be all right angles are congruent, or is it going to be definition of right triangles? The proof decides. Well, okay, let's plan ahead. If I look at the next given, CA is congruent to AB. What type of triangles are these? Well, these are right triangles. What part is CA and AB? Well, look at it. It's the longest part, and it's across from the right angle. So again, this is my hypotenuse. So I will be using HL for this one. So if I'm using HL, step 3 should be that triangle ADC and triangle BDA are right triangles. Make sure that we're not using angles here, we're using triangles. And what's the definition of that one? Well, if I have a right angle in a triangle, that's a definition of right triangles. Alright, we haven't included that given CA is congruent to AB, given. And then what else have we not included in our proof? It looks like there is a reflexive side. So I can say, okay, AD is congruent. That side is congruent to itself. It's in both triangles. And the reason why is the reflexive property. So why are the triangles congruent? Triangle CAD is congruent to triangle BDA. And the reason? Hypotenuse leg. The hypotenuse, the long sides of the right triangle are congruent, and a leg, just another side, is congruent. So if I'm looking at the next proof, alright, this proof is interesting. So I'm given right angles. So that means it's HL, or it could be side, angle, we don't know. So let's plan ahead. So if I start my statements and my reasons, let's kind of slowly think about it. Which one is it going to be? Because that changes one step in my proof. Alright, so if angle A and angle C are right angles, given. Alright, let's put a right angle on each of those angles. So let's plan ahead. Is this HL or not? Well, then it gives me AD is congruent to CD. What other parts would I know are congruent? Wouldn't I know this reflexive is congruent? Well, yeah. So if I look at this proof, this, I have the hypotenuse, that longest side, though that is congruent. And I have a set of sides that are congruent. And it's a right triangle, so guess what? This one is HL. So if I'm looking at step 2, I never put, they are right angles. So now I'm going to have to say, well, triangle ADB. Did it have to be ADB? Of course not. I'm just using any 3 letters to represent this first triangle. And triangle CDB are right triangles. So what's the reason for that? What allowed me to do this? So if I have a triangle with a right angle, that means I can make the conclusion that they're right triangles because that's the definition of a right triangle. All right, 3. Well, we haven't included the given up here where it says AD is congruent to CD, given. And then what would be next? Well, step 4, what else haven't I included in the proof? The reflexive side. So BD is congruent to BD, reflexive property. So why would these triangles be congruent? Triangle ADB is congruent to, again, you can have your own lettering on that one as long as the corresponding parts are the same. So why would that be? Because of HL. Did you notice it wanted me to prove something else? All right, so we actually have more steps to do. All right, let's think. If I know I'm trying to prove that right triangles, I'm trying to prove that BD bisects angle ABC. This is for those advanced people out there. If I'm trying to show that angle B is going to be bisected, which set of sides or angles is going to help me do that? Hopefully you're thinking angles. If I now show that angle ABD is congruent to angle CBD, because corresponding parts of congruent triangles are congruent. Didn't I just show that those angles were congruent by CPCTC? So if I have 2 congruent angles, didn't that show me that BD bisects angle ABC? And what would be the reason? Well, that's what the definition of a bisector is. It cuts an angle to 2 congruent parts. And vice versa, if an angle is cut into 2 equal parts, that implies that it is a bisector. Definitions are reversible. All right, for the last one, I would like you to pause the video. When you're done trying it on your own, go ahead, hit play, and you'll check your answer. So pause it now. Okay, take a look at the proof. See if you got all the steps correct. So this one was because of HL. The hypotenuses were congruent. And the leg was congruent in a right triangle, so that is hypotenuse leg.